The Sherman tank is burning on a battlefield in Europe. Its armor is torn open, its crew is gone, and the vehicle appears to be finished. For the soldiers watching, it is another tank lost to the war. But thousands of miles away, something very different is happening. Inside an American factory, another Sherman is already moving through an assembly line. This was the part of American industrial power that German planners struggled to fully appreciate. The United States was not simply building tanks. It was building a system capable of replacing them. The Detroit tank arsenal became one of the clearest examples. Chrysler began developing the facility in 1940, when the company had little experience producing tanks. Yet the plant delivered its first tank in April 1941, months before the United States entered the war. The transformation was remarkable. A company accustomed to building automobiles had taken military blueprints, reorganized its machinery, trained thousands of workers, and created a production system capable of turning steel, engines, armor, weapons, and countless smaller components into finished fighting vehicles. And this was only the beginning. The Germans were trying to destroy American tanks at the front. American factories were preparing the replacements behind them. The crucial question was no longer whether America could build a tank. It was how fast the entire industrial system could build another one. And the factory itself was only the visible part of the machine. Chrysler had never built a tank. Then the Army asked it to build thousands. That was the strange starting point of America's tank production revolution. American automobile companies already understood mass production. They knew how to organize assembly lines, standardize components, move materials efficiently, and turn thousands of separate parts into finished vehicles. But a tank was not simply a larger automobile. It carried thick armor, a powerful engine, heavy weapons, tracks instead of wheels, and mechanical systems designed for a battlefield rather than a highway. Chrysler engineers reportedly studied tank designs at Rock Island Arsenal before creating their own production system. The challenge was not to make automobile manufacturing slightly better. It was to adapt the entire philosophy of mass production to a machine built for war. And that required a crucial change in thinking. The Detroit factory did not have to manufacture every part itself. Instead, specialized companies could produce engines, armor, transmissions, electrical equipment, tracks, and thousands of smaller components. Those pieces could then converge on the final assembly line. That meant the tank plant became the center of a much larger industrial architecture. The secret was no longer simply how quickly workers could build one tank. It was how quickly an entire network could supply the pieces needed to build thousands. And the answer began with something that looked less impressive than a tank: the parts network behind it. The tank plant did not manufacture a tank alone. Hundreds of other factories were manufacturing pieces of it. Around Detroit, engineers, machinists, welders, inspectors, managers, and subcontractors became part of the same wartime machine. Each had a specialized task, but together they created something much larger than any individual workshop. The Chrysler tank arsenal depended on more than 700 subcontractors, according to the Detroit Historical Society. Their work stretched far beyond the arsenal's walls, supplying components that eventually converged at the final assembly line. That changed the meaning of a factory. The arsenal was not simply a building where workers assembled tanks. It was the final meeting point of a regional manufacturing system. At peak production, roughly 400 employees worked at the arsenal, with operations continuing around the clock. Every shift mattered. Every supplier mattered. Every standardized component had to arrive when it was needed. The system's real strength was coordination. And once those pieces arrived, speed became measurable. In 1 month, one American tank plant approached 900 completed vehicles. December 1942 revealed what the system could do once it reached full rhythm. According to U.S. government acquisition records, the Detroit arsenal produced 896 tanks during that single month. Inside the plant, the number began as thousands of separate movements. Components arrived from suppliers. Armor sections moved into position. Engines, transmissions, tracks, weapons, and electrical systems passed through specialized workstations. Workers repeated the same operations, while inspectors checked components before the next stage. The process was fundamentally different from building each vehicle as an individual project. Instead of depending on one craftsman to complete an entire machine, the work was divided into repeatable tasks. That repetition created speed. More importantly, it created consistency. Once engineers discovered a faster method or corrected a production problem, the improvement could be applied again and again across the line. The result was not simply a fast factory. It was a factory that could reproduce its speed. But Germany's problem was not simply that America could build fast. It was that America could scale the process. The secret was not one enormous assembly line. It was hundreds of smaller lines feeding it. Detroit was only one part of the American production machine. Ford built M4A3 Sherman tanks, while General Motors divisions produced tanks, tank destroyers, engines, chassis, and other essential equipment. Fisher Body, Cadillac, Buick, Pontiac, and other industrial companies also contributed to the wartime effort. That created something different from a single factory. Production was distributed across a vast network of specialized manufacturers. One company could concentrate on engines while another produced armor, transmissions, or other components. Their work eventually converged into complete fighting vehicles. This mattered when problems appeared. If one supplier faced a bottleneck, the entire system did not necessarily stop. Production capacity existed at multiple levels, spreading the burden across different factories and industrial centers. The result was a powerful form of redundancy. America did not need every factory to build an entire tank. It needed enough factories to keep the system supplied. That is what made rapid replacement possible. And this is where American standardization collided with German production philosophy. The surprise wasn't that Germany could not build tanks. It was that the American system could keep rebuilding the same kind of war machine. It is tempting to reduce the difference to quality versus quantity. That misses the real story. German armored vehicles could feature sophisticated engineering, heavy armor, and powerful weapons. But increasing complexity could also make manufacturing, maintenance, and standardization more difficult. The American approach emphasized something different. Standardized vehicles produced in large numbers and supported by an enormous logistical network. The goal was not to make every machine unique. It was to make the same basic machine repeatedly, repair it efficiently, and keep replacement parts moving toward the front. Germany's production also increased dramatically later in the war. So the story is not that Germany simply could not build tanks. The deeper question was how efficiently each industrial system converted factories, materials, and labor into usable armored formations. Even intelligence officers faced uncertainty. Studies of the German tank problem show how difficult it was to estimate enemy production from captured serial numbers. Then the battlefield supplied the most brutal test of the system. Destroy one tank, and you have destroyed one vehicle. Destroy a production system, and you have to destroy thousands of machines behind it. On the battlefield, a Sherman knocked out in Normandy or Italy was still a loss. A crew was gone, equipment was destroyed, and an armored unit had one fewer vehicle. But that loss did not necessarily mean a permanent reduction in American armored strength. The Detroit arsenal shows why. During the war, it produced 22,234 tanks, mostly M4 Shermans, accounting for roughly 1/4 of wartime U.S. tank production. Yet replacement meant far more than sending another hull forward. A tank needed an engine, transmission, tracks, weapons, radio, ammunition, fuel, spare parts, mechanics, transport, and a crew. Every one of those requirements depended on part of the industrial and logistical network. That was the real American advantage, system-level replacement capacity. The factory could build the vehicle, but the network could supply what kept it fighting. By this point, the numbers were no longer impressive. They were changing what commanders could afford to risk. The Germans were looking for the factory that made America's tanks. The answer was bigger than any single factory. American industrialization turned manufacturing consistency into military resilience. The tank was only the final product. Behind it stood machine tools, workers, suppliers, specifications, transportation networks, and managers coordinating thousands of separate operations. That created a crucial difference between individual craftsmanship and a repeatable process. One exceptional mechanic could rescue one damaged vehicle. A standardized industrial system could repeatedly produce vehicles, replacement parts, train procedures, and the tools needed to keep them operating. No single factory created the American advantage. It was the ability to make hundreds of factories, suppliers, workshops, and transport networks function as parts of one enormous machine. The result was more than production speed. It was resilience. Battlefield losses could be absorbed because replacements were already built into the system. And that may be the most overlooked part of America's wartime industrial story. The most powerful American weapon may not have been the tank. It may have been the ability to build another one. The Sherman mattered, but so did everything behind it. Factories, spare parts, mechanics, fuel, transport, and trained crews. That industrial network turned battlefield losses into replacements and kept armored units moving. So, where are you watching from, and which overlooked WWII production story should we investigate next?